Okay, let's see if that works. Okay. Good. Now, I want to talk a little bit about the difference between programming and metaprogramming. So, generally, when we talk about a program, we talk about taking some user input, doing something with it, and producing some output. So, regular programming is input, processing, then some output. And that can potentially be looped. I hate drawing ski art loops, but you could imagine this here, and then that would go feed back into here. Right, that can go in a loop, and with event-based programming, that's what's going on. That's regular programming. We have some input, we do some processing, we create some output, and potentially we take more input and do some other processing based on that. Right, now we're talking about metaprogramming. In metaprogramming, things are a little bit different. So we get some, our input is a program. So we get some source code or some, we get a program in some form, we get a program, we do some transformation on that program or part of the program, and then we create another program. And I think just one program, not sure, not a native speaker. Alright, let's say code. Code is easy. We have some code and some transformation that creates more code. And that potentially also happens multiple times, like that. It can go, oh, I get this. It can go back and forth between things. So, if we look at this, those two things don't seem to be that different, actually. The only difference is that we have code as input and code as output, and that transformation is also being done by code. And you can even do things where the code you create can be used to transform other code. So that can be recursive, but so can this. You can create some output that then creates some input for another stage of processing, and the same can be done in metaprogramming. You will note that in this definition where metaprogramming is just code as input and code as output, I didn't mention templates at all. And the reason is because they are not fundamental to how metaprogramming is done. Metaprogramming is really just taking code as input and producing some code as output. And then running that code at some point, but not necessarily. Sometimes you just want to pre-process your code and ship that to somebody else, who then runs it, hopefully. Otherwise it would be useless. And that is basically already all I can say about metaprogramming. So, thing is that template metaprogramming gives you the ability to create code. You can create templates, allow you to create fully formed code from code fragments. So what you can, for example, do, you can write a sort template that's templated on a type T, and that T then you get a value of, and if value greater than, oh yeah, let's not do sort, let's do max. It's templated on some type T and gets a value A of that type and a value B of that type, and if A is greater than B, we return A, else we return B. That's all there is. In this case, this is not very much code you have to write, but it still is something that people would do traditionally with a template or with a macro. And know that you could even do something like this. Well, if there is a comparison defined between T and U, and there is an implicit conversion defined between T and U, then this code will also work. This would allow you to compare an integer to a double, and you would then get a double back. And of course, then the computation of the return value would be hard. So in D we just put auto and call it a day. So, what about this? Is it that's intrinsic to metaprogramming? Because templates right now, they allow you to play with fragments. What I want to do, what my definition of metaprogramming allows me to do, is I want to be able to take a max function that's for integers and make it into a max function for doubles. And I think I just wrote min. Yeah, if A is less than B. Alright, then this is min. So, I could do this via simple text processing. I simply replace every int by T. And you will notice this looks exactly like the max template we just had. However, that is not something that template metaprogramming currently allows us to do. And why can't we make this into this? Since that should work, right? And the answer is we are missing the ability to clone a function and replace the parameter and the return types ourselves. But that is what we would need to have proper metaprogramming. So how can we do this? Well, the answer is we need some way to get a programmatic form of this. We need some way to get some kind of representation that would allow us to change the parameter types of this code in order to get proper metaprogramming. In other words, we need to be able to reflect on the code. We need to be able to create a reflection, to create some kind of abstract syntax tree, some kind of program syntax notion that we can then modify and change. And that is usually called reflection. And that is what we will be talking about today.